Hi, my name is Dan, and this video is one in a short series of videos I'm doing about memory cells using digital electronics, which is part of a wider suite of videos that I'm doing, which is working towards creating a 4-bit CPU computer core simulated using this software, which is called DigitalWorks. So there is a roadmap of where we're going in the description below. And there is also a link to this software, DigitalWorks, which is free to use. Um, so please get it, use it. In this particular video, we're not actually going to create another macro. Most of the videos are about creating elements that are eventually going to all come together. In this video, I really want to just talk about an aspect of digital computing uh, and the digital electronics behind it, which is to do with time. So you're probably aware that computers have this time element, and computers slowly over, not actually that slowly, have been speeding up in their history as they go faster and faster. And you might have heard the term clock speed, which is how fast a computer works. And what happens during a program being run is that there are various things that happen over and over again that fetch the instructions from the memory, interpret the instructions, carry out the instructions, uh, do some arithmetic possibly, move some stuff about. And programs are a set of sequential instructions. So they're one instruction, then the next instruction, then the next instruction. In order to make this work, there is a fundamental part of digital electronics that's needed, which is to have a input signal that pulses, that regularly goes from high to low, up and down, and this is called the clock. And in modern computers, obviously, the clock goes at incredibly fast speeds in order to make these things happen. Um, DigitalWorks has a built-in clock, so we're going to just throw that clock in and we're going to wire it up to an LED output. We're already simulating, so we can see that clock is driving this line to go up, down, up, down, up, down, up, down. And inside DigitalWorks, we are able to change the speed of this clock. That's 1 hertz, which is 1 time a second. If we go at 10 hertz, it's flickering quite quickly. And the fastest it can go is 100 hertz, which is so fast it just looks like a kind of buzzy blur. Let's bring that down. About that. So in terms of watching things happen and what happens, 1 hertz is quite a good speed to watch stuff happen. Um, and the point of talking about this at this stage in this sequence of videos is that in the first video, so the previous one to this, I showed you a circuit called an SR latch, which allows us to store the state of a line as either a 1 or a 0. And if you use your imagination, you can see that this can be used to remember binary numbers if you've got several of these connected, one for each digit. But typically what you're wanting to do is to have actions work synchronized with other actions that are going on. And it's this synchronization that uses the clock. And how this applies to memory circuits is that we're going to want to adapt our memory circuit so that it only works as the clock tells it to. Okay. I'm not actually going to do this in this video. This was about some of these ideas and the theory. And so in the next video, I'm actually going to show you how to turn an SR latch into what's called an SR flip-flop, in that it uses a clock trigger to make it work. But that's the next video, so that's it from me for now.